So hello everyone, welcome to Physics Wallah guys. Hope you all are doing well and your preparation is going to the up to the mark. If my voice is clear, please let me know. If my voice is clear, please let me know. If audio and video everything is clear, please let me know. Hello everyone and hello everyone. Let me check from myself also. Okay. So hello everyone and welcome to Physics Wallah guys. So in the last class, yes, I think everything is okay from my side. If anyone is there, please let me know. If all good, all well, then let's start. In the last class guys, we have covered the first very important thing, that is the operation on signal. Okay, and operation of signals, in that we have basically covered one of the most important topic. Hello Pranav. One of the most important topic, that is nothing but my sampling. Hope you have some feeling of sampling. Though sampling is the topic that we are going to cover throughout the course. Okay, and mind it that it is one of the most important topic we have. So sampling we have covered in the last class and we have covered TS about that. But before that, let me introduce myself. My name is Pankaj Singh. I have in total nearly 15 plus years of teaching experience. I have covered many batches in top reputed organizations. Hope you all know about me, and I'm here to take this comprehensive course in Physics Wallah, that is Physics Wallah Gate Wallah English channel. Okay, so now let's start now. So what we have covered in the previous lecture, let us recap in just 2 minutes. I said that we have a signal x of t. I have a signal, let's say I have a signal x of t, which is in general continuous in nature. And I told you that what do you mean by a continuous time function? What is continuous time function? I told you that if the functional value is defined at each and every time over the bound where a and b, a comma b are open interval like this, and if a functional value is defined at each and every instant of a time t, then this is said to be the continuous time signal. Okay, so we basically want continuity in x-axis as well as continuity in y-axis for continuous time analog signals. So I have differentiated 4 important categories last class. First is CTS signal, continuous time signal. Second is discrete time signal. Then we have covered analog signal. Analog means continuity in time as well as continuity in y-axis also. That's what the analog means. And fourth signal we have covered is a digital one. So what is a digital signal? Digital signal means that it will take a fixed value on y-axis. For example, your binary signals. Your binary signals will take the fixed value, that is 0 and 1 on the y-axis. That's why we are calling it to be a digital one. Okay. Very good evening, Sachi. Now the point is that we have covered in the last class that this is the x of t, then we have to sample it, and this is the general symbolic representation of sampling. Good evening Sachi, good evening Pranav. And we say that the sampling is done over NTS time. And what do you mean by TS? Good evening Vaishnavi. So what do you mean by TS? This TS, I am calling it to be a sampling interval. This TS, I am calling it to be a sampling interval. Okay, I call this TS as sampling interval. And I told you that what is the physical significance of TS? TS is basically associated with the speed of the switch, and this speed of the switch we called in the last class as a Fs. Fs we call it to be the sample rate. If you remember this, we call it to be the sample rate. Okay, so this is the sample rate. So what I am saying is that if more is the Fs, less is the TS, because you know that Fs, okay, is equal to 1 by Ts. This is a very, very important relationship, guys. In the last class itself, I have derived this one. In the last class itself, I have derived that is Fs is equal to 1 by Ts. Okay. So this is one of the most important topic that we have covered in the last class, though I'm just recapping it. If you haven't covered this one, please go and watch that particular lecture where I have covered each and every aspect of sampling. Okay. Next is that, see, we will get x of nts after this. We will get x of nts. X of nts is also a discrete time signal, but we associate this ts. What is n? N is an integer. What is n? N belongs to integer. N belongs to integer. Okay. Who is asking? Cyan. Cyan, n belongs to integer. So we are taking the integer values of ts. Okay. So this n belongs to the nothing but my integer, and this is x of nts. And this, what is the nature of this x of nts? This x of nts is, for example, like this. So for example, it is, you have a 0, you have a ts, you have a 2ts, and so on. You have a minus ts, you have a minus 2ts, and so on and so forth. So on and so forth. And we have a samples here. Each and every time we have a samples like this. We have a samples like this, we have a samples like this, we have a samples like this, and like this. Okay, so this is what my x of nts is. This is what my x of nts is. But the point is that we want, this is also discrete in time, but continuous in y-axis. See, it is free to take any value on y-axis. This means that it is continuous in y-axis but discrete in time. But we don't want to associate the ts every time. We want this to be the integer. So if you want to get an integer, what you want is that divide by ts, that divide x-axis by ts, and hence what you will get 0 here, you will get 1, you will get 2, you will get 3, you will get -1, you will get -2, and so on and so forth. And these are the samples that I am getting at each and every time. Each and every time, same, everything is same. But this time I call this as x of n. This time I called it as this x of n. So look at the journey that I have made in the last class, that we have a continuous time signal. We have a continuous time signal. We pass it through a basic sampler whose sample rate is defined to me, which is fs and or ts, whatever it is defined, and we are taking the integer values of ts, sample at integer values of ts, and the rate, the gap between the two sample is minded that it is a constant. So this is the gap, the gap is a constant. That's why we call it to be a uniform sampling. So we are calling this to be a uniform sampling. So we have a uniform samples we have, and this we call it to be the x of n. And in the last class itself, okay, I said that x of n, okay, x of n can be also written in this way, like a comma b comma c comma d comma e, like this. Here bracket is closed. You can represent this x of n in this form also, and this form I call it to be a tabular form. Okay, this form I call it to be a tabular form. Okay, so that is a tabular form, or nothing but my in the form of sequence. We have most of the time, 90% of the time you will get in this form. Or you may represent this x of n in this way also. Sometimes x of n we call it to be in this way also, like that it is c at n is equal to 0, it is d at n is equal to 1, it is e at n is equal to 2, it is b at n is equal to -1, and let's say a at n is equal to -2. This we call it to be a mathematical form. That is a mathematical form. Mathematical form we have. Okay, so this we call it to be the mathematical form. So what I want to say is that we may have many forms. Either we have a graphical form, or we have a tabular form, or we have a mathematical form, and that's we call it to be discrete time functions for fixed ts. Mind it that ts is defined every time. Ts is fixed. And what is ts? Ts fixed, sorry, TS is fixed and it belongs to a real number, okay? This belongs to a total real number. So this is a real number we have and we are doing a integer sampling. So that's what the essence we have covered in the last class. And I told you one very interesting thing, that less is the TS, more number of samples we will get, and hence the exactly DTS will represent the CTS form, okay? Exactly DTS will represent a complete CTS. That's what we covered in the last class. And we call this the representation, that how exactly your DTS is representing your CTS. We call this as a what? Resolution. So we have used the word resolution. Let me define this resolution in a very formal manner. I am saying the resolution in this form, that this DTS, that this is the DTS of this CTS. So how close this DTS is exactly representing this CTS is known as a resolution of a function. So if we have a more number of samples, then the resolution is very, very high. This means that this DTS will exactly represent the CTS part. So that is the whole class that we have covered in the last one, okay? That is the whole thing that we have covered in the last class. Yes, TSs are higher the resolution, yes. But now let us cover a very interesting thing. Now we have, what we are going to cover in today's class, okay? What we are going to cover in today's class. Now we have x of t, and we have x of n. For corresponding x of t, we have x of n, okay? Now I want to operate this signal. Now what do you mean by the word operation, sir? So what we are going to cover today's class, we are going to cover the operation on xt and xn. So this is our main agenda for today's class, that we are going to cover the operation on x of t and x of n. Okay, now what do you mean by the word operation, that we are going to cover in this class? Okay, let's start now. First of all, understand what do you mean by the word operation. See here, consider this signal, okay? Consider this signal. For example, I have this signal. Okay, let's take one very interesting signal. Let's take one signal. Okay. Okay, fine. So this is the one signal that I am taking here. And let us take the endpoints to be in this form. So this is, let's say, -3. This is 4. And that is 5. A general signal I am taking, I am calling it to be the x of t. Okay, and this I am calling it in t domain. Now, suppose I want to characterize this signal mathematically, then I will write that x of t is what? 5 for t greater than -3 less than 4 and 0 else. We will say in this manner. We will say that this is what the characterization of x of t. So we have these are this we calling it to be this one, these all, and this is, we call this as, okay, sorry, we call this as end point of a function. This I am calling it to be the end point. Okay, this is what the end point of a functions are. So this is an end point of a function. Okay, this I am calling it to be the end point of a function from here to here. Let's take this one. This is calling it to be end point, and this I am calling it to be the height of a function. So this endpoint defined from -3 to 4, and this is what the height of a function is. So this I am calling it to be the height. So this is height. Height is how much? 5. And if I want to define the width of a function, then this is the upper bound, which is 4, and this is the lower bound, which is -3. So what I'm saying is that the width W is upper bound minus lower bound. Width is upper bound minus lower bound. This is the whole width we have graphically. And what it is nothing but my 4 minus of -3, which is equal to 7. So this width is 7. So suppose what I want to say is that, very simply, that suppose I want to characterize this signal x of t, then I will say that x of t formally, let me change the color. I will say that my x of t is having height h is equal to 5, width is equal to 7, and endpoints as 3 minus 3 comma 4. Okay, and this I am calling it to be the some function, random function. I'm not naming this function. We will name it in future classes, but the point is that these are the 3 parameters which are associated with this signal. Now what do you mean by the word operations here? In general, the operation means that I want to change either the height, I want to change either the width, I want to change either the endpoints, because it is required in our signals, in our complete signals, Fourier transform, Fourier series, whatever, or in complete signal processing. Sometimes I have to reduce the width of a signal, sometimes I have to enlarge the width of a signal, sometimes I have to change the endpoints of a function, sometimes I have to change the height of a function. This is what the meaning of nothing but my complete operation is. But out of these two, let's see here very closely, look at that. So out of these two, the width is a function of -3 comma 4. This means that width is a function of x-axis, endpoint all are the points on an x-axis, and height is the function of y-axis. So what I'm saying is that these two are x-axis points, I will say, and this I am calling it to be a y-axis point. Y-axis points. So let me define the operation in this way. Say here, operation is to change fundamental characteristics of signal. That is width, height, endpoints. Okay, so this is what the meaning of operation here. Operation, this means that I want to change the fundamental characteristics of a signal from which the signal is defined. Here it is a height, width, and nothing but my endpoints of a function. Now since these are two axes are involved in both these operations, so we have, in general, operation is of two types. So I am saying that operation, let me say in this way, that operation is of two types. Let's call it to be, one is to be x-axis operation, and this I am calling it to be a y-axis operation. Okay, so I have two kind of operations. One is a x-axis operation and other one is a y-axis operation. Mind it that in the x-axis operation, the prime motive is to change what? Endpoints and width. But here the prime motive is to change what? Height. Okay, so whenever I say that I have an operation, then I want to either change the endpoints and width, or I want to change the height of a general functions x of t or x of n. X of t is defined, x of t height is defined, x of t width is defined, x of t, let's say, endpoints are defined. Now I want to change all these points. So let's take one by one each and every operation in detail. Okay, let's take each and every operation in detail. So first heading that I am taking here is first heading that I am taking here is first I want to take a continuous time function. So first heading I am taking it to be a x-axis operation. Let's take the x-axis operation. If any doubt if you have, then please do ask the doubt, guys, because it is very important that if you make this session to be interactive. If you want an interactive session, then the doubt must be come into the picture, and please share this lecture to the maximum students so that maximum students get benefited. If you have any kind of doubt, then do ask. Please use my complete 15-year teaching experience. These are the quality lecture that I give always in the paid batches, and if you respect this lecture, then please try to exploit as much as you can, and please try to ask as many doubts as you can. Okay, so let's start. X-axis operation. So the x-axis operation is mainly of three types. Okay, mainly of three types. One is let's say we have a time shifting, we have time scaling, and we have time reversal. Let's take this in detail. So we have three kind of operations. One is the time shifting, time scaling, and time reversal. And this is one of the most important topic we have that is going to cover. Now, what do you mean by time shifting? Listen carefully. Let's take time shifting first. So I'm taking time shifting first. Let's take this as a signal, okay? Suppose I have a signal, this one. A random signal I am taking, this one, having the endpoints to be equal to minus a comma b. This c. This I am calling it to be the xt. Now this is plus infinitive. This is axis t. Okay. This I am calling it to be the plus infinitive, and this is I am calling it to be the minus infinitive. Now what do you mean by the time shifting operation? Listen carefully. See, if this is x of t and this is the endpoints of minus a comma b, then either you will shift this signal to the right or shift this signal to be the left. Okay. So if you want to shift this signal, say x-axis to the endpoints, listen carefully, that shift this signal to the right or shift this signal to the left. Now the point is that whenever you shift this signal to here, we call it to be a time delaying. Why I am calling it to be time delaying? Why I am calling it this to be time delaying? Because these are the point not yet came. Okay, these are the point that my function is defined, and these are the point will come after some time. Is it clear? Because I'm assuming that my function will move from minus infinitive to plus infinitive. So this I'm calling it time delaying. But if you shift this function to be here, okay, then we will call it to be a time advancing. Time advancing. The most important point is that what is the general format of time delaying? The general format of time delaying is very simple. It is, if this is x of t, then this should be x of t minus alpha. Listen carefully. Where alpha belongs to a real number, mind it. This is one of the most important point that you have to take care. Alpha belongs to the real number. So this is what the general format of x of t minus of alpha. So whenever you shift the signal towards let's say plus infinitive by alpha amount, then you will write to be x of t minus alpha. And why you are writing, then you will know in today's class itself in the last one. Okay, I will when I combine the whole operations, time scaling, time reversal, time shifting in one topic, then you will come to know that why I write t minus of alpha. You just wait. And if you want to shift here, then the general format here is x of t plus alpha, where alpha again belongs to a real number. What is the most important point here? The most important point here is that whenever you shift the function, whenever you shift this function, then the shifting factor is nothing but my alpha. So delaying is minus alpha and advancing is plus alpha. Let's take this by one example, then only you will understand. For example, I have this function. Let's take, I have this function. For example, I have, this is 0, this is 2, that is 4, that is 6, this is 2, and that is 4. This I am calling it to be the x of t. This I am calling it to be x of t. Listen carefully. Okay? This I am calling it to be x of t. Thank you, Geeta. This I am calling it to be x of t. Now my point is that, for example, plot, suppose someone asks you that plot yt, which is x of t minus 3. Suppose someone asks you this, yt which is x of t minus of 3. Now what is x of t minus of 3? What it says, see here, it says very clearly that shift this signal towards right by factor of 3. By factor of 3. So this means that whatever you have here, start from 0 to 2 to 4 to 6. Okay, then this signal will be shifted in this right. So what you have to do is that add all the points by the factor of 3 here. Add all the points by factor of 3. See here. So if 0 is added by 3, it comes to 3. 2 is added with 3, it comes to 5. 4, 3, 7. 6 plus 3 is 9. This means that this signal will now comes like this one. This one. And what are the points now? This is 3, this is 5, and this is 7, this is 9. And 4 plus 3, 7 and 9. And this value is 2. Mind it that my y-axis is not changing. How y-axis will change? Y-axis will change only when there is a parameter change in the coefficient or you add something. If you multiply something by a constant here in the coefficients, then only y-axis will change. As long as there is a change in this bracket, then the y-axis values will remain same. Okay. Now look at the point what we have done. So this is having a width equal to 6. Okay, but the end points are 0, 2, 4, 6. But look at the width here. What is the width? Can you define the width? Width, I told you in CTS, is the upper bound minus lower bound. What is the upper bound here? It's a 9, it's a 3. So 9 minus of 3, which is equal to 6. 9 minus of 3, which is equal to 6. This means the width will not change. Width remains the same. Height also not change because this is the x-axis operation. But what changed? The change is the endpoints. So this endpoints, now 0 becomes a 3, 2 becomes a 5, 4 becomes a 7, and 6 becomes a 9. That's what the meaning of we delayed the signal by factor of 3. We delayed the signal by factor of 3. Now, suppose in the same question, suppose someone asks you that plot same function, plot y2t, let's call it to be y2t, to be equal to, let's say, x of t plus 2, for example. Someone asks you like this, same question, exactly same question, but I want x of t plus 2. Now what you have to do, you have to take this signal and shift this signal towards left by factor of 2. This means that you have to, what, this time you have added the points, this time you have to add the points. Now what you have to do, you have to subtract the points. So when you subtract the points 2 here, it becomes a -2, it becomes a 0, it becomes a 2, and it becomes a what, 6 minus 2, which is 4. So what the signal that I will get is this one. See, what the signal that I will get is this one. Okay, sorry. Yes, I will get this one. So this points, how will you find the points? Simply subtract the points by 2. Simply subtract the points by 2. This means that this becomes a -2, 2 minus 2 becomes a 0. Next point is 4, 4 minus 2 becomes 2, and 6 minus 2 becomes a 4. This value is 2, this value is 4, because I told you that y-axis will not change. This means that, see, look at this, this is the function which is x of t plus 2. That's what the function we are performing, x of t plus 2. Now my point is that, can you change the width? Can you tell me the width of this function? Can you tell me the width of this function? Okay, sorry. Can you tell me the width of the function? Yes, we can find. The width of the function still is what? 4 minus -2 upper bound minus lower bound, which is still 6. So width comes out to be 6. Okay, so width is 6, height is 4. Thank you, Pratisha. Width is 6, height is 4, and that's what the meaning, I will say that this is how a shifting is performed. So the complete signal, this one is now shifted towards right or left, by this amount. Is this point is clear to you? Okay, is this point is clear? So that's what the meaning of time shifting operation is. So we have shifted in time shifting operation. Let's revise this one. In time shifting operation, what? Change, I will say that change endpoints, maintaining width and height constant. Maintaining width and height to be constant. Okay. Now, so this is what we call it to be the time shifting operation is. Now let's move to a time scaling operation. Now again, let's take this one. This is time scaling. So this is B, that was A. Guys, I will provide the notes also. Okay, I will give you the notes also, and notes you can download from your there is a Telegram channels which is written, I think, in the description box. So please take the notes and do benefit it with all kind of notes we have. This is the elaborated notes that I am giving you, okay, in the clear-cut manner. Fine. So time scaling. Fine. What do you mean by time scaling now? See, a time scaling operation says that, see, suppose if we have a signal, this is the signal we have, general signal I am taking, and this is the point minus A, comma B, and this point is C. This is what my x of t is. Last operation will change the width. Last operation, sorry, not change the width, change the endpoints. Now this operation, what is the objective of this operation? The objective of this operation is to change the width of the function. What is the width here? What is the width? What is the width here? See, if you look at the width, then the width here is is B plus A. Yes or no? This is what the width is. Now I want to change the width. How will you change the width? And what is the format of the width? See, the scaled version, scaled format of xt is yt is equal to x of alpha t. Mind it, yt is equal to x of alpha t, where alpha again belongs to the real number. Mind it, guys, that's a very important point. As long as x-axis operations are performed, you do not have to worry about the position of this alpha. Alpha may be always a real if it's inside the bracket, because this axis is always real. This axis may be a imaginary also, or complex also, whatever, but this axis is always real. Now my point is, how will you perform this x of alpha t? How will you perform this x of alpha t? See here, simply divide the whole point, simply divide the whole endpoints by alpha. Whenever you have to perform x of alpha t, how you will get, why you are dividing, why you are adding, why you are subtracting, I will give you in a moment that why I am dividing this, why I am subtracting, or why I am adding. I will give you the answer in just a moment. Just wait. What I am saying is that whenever you have to perform the x of alpha t, then simply divide it by alpha. Simply, whatever it says, whatever the values it says, simply divided by alpha. Now my point is that, see, if now you will find out the width, now if you are finding the width, okay, then the width comes out to be, that is the b minus of minus a divided by alpha, and hence it is a b plus a by alpha. This is what the formalized width of a function. Let's take an example. Then how will you say that this is the time expansion, time compression, and whatever? Let's see. Let's take an example, then only you will understand. Suppose we have x of t. Example. Suppose we have x of t, again same function. Let's take this way. This is the function. Let's take a general function. This is 0, this is 2, and that is 4, and this value is 2. This is what my x of t is. Now let's take the all possible values of alpha. Here alpha, I said that is a real number. So let's take the all possible values of alpha. I am saying that plot y1t to be equal to x2t, y2t to be equal to x of t by 3, y3t to be equal to x minus t, y4t to be equal to x of minus 2 by 3t. Suppose someone asks you that plot all these signals. Okay, let's do it one by one. Now what I said, how will you plot y1t? Guys, how will you plot y1t? Simply what? Divided by 2. Simply divided by 2. Now when you divided this signal by 2, so I am taking y1t divided by 2. This means that this value, sorry, this value is 2, this value is 2, and this value is 2. This means that this will comes like this. This is 0, that is 1, and that is 2, and this value is 2. This is what my y1t is. Very simple. Let's take y2t. Let's take y2t now. Sorry. Let's take y2t now. Let's take y2t. What is y2t now? y2t is a what? X of t by 3. This means that you have to simply divided by, instead of 2, what you have to take? What you have to take? Divided by 1 by 3. Divide by 1 by 3. divide by 1 by 3. And when you divide the whole thing by 1 by 3, simply divide by 1 by 3, then the point automatically you will get. What the point you will get? Come on. The point I will get is this one. Don't you think? Is 0, and 2 divided by 1 by 3 becomes 6. 4 divided by 1 by 3 becomes 12. We will talk width in later. Don't worry. Let's talk Y3D first. Let's talk Y3D first. Now what is Y3D? What is Y3D? Instead of dividing it to be this is 0, this is 2, this is 4. Dividing by any number, we are dividing it by a -1. So just divide by -1. So simply divide by -1, divide by -1, and divide by -1. Now see, when you divide it by -1, then what you will get is that 0 becomes 0, 2 becomes a -2. Okay. So now this axis, which is the signal which is in first quadrant, now change the quadrant to left one. Yes or no? So it becomes a -2, it becomes a -4. This means that what you will get, see, I will get, don't you think that I will get this signal? So this is 0, this is -2, and that is a -4. Hello? I will get this one. This is 2. Sir, don't you think that this is a mirror image? This signal is a mirror image of the signal with respect to y-axis. This is the mirror image with respect to y-axis when you perform x of -t. This is very famous operation. We call this as time reversal. This is a very famous operation. We call it to be the time reversal. What do you mean by time reversal? Simply reverse it. Simply take the mirror image, whatever you have, simply take the mirror image with respect to y-axis. So if you have this is a y-axis, then take it as a reference, and whatever you have here, just flip it here. So that's what the time reversal, or we popularly call it to be flipping. So time reversal is a special case of time scaling where alpha becomes a -1. Alpha becomes a -1 simply. Now, next point is that, see here, what is the next operation? We have, see, we have reversal because minus sign is there, and now we have to divide it by 2 by 3. We have to divide it by 2 by 3. This means that what is y4t? What is y4t? Y4t is reversal. Of course, the reversal we have, because the minus sign says this, that it is a reversal. And now what we have, this is 0, this is 2, this is -2, sorry, and this is a -4. Now what we have to do is that divided by the factor 2 by 3. 2 by 3. 2 by 3. Whatever you have. So that the complete function will be like this. Whatever we have, this is 3, 6 by 2 cancel, 6, this becomes a -6. Oh, sorry, this becomes a -3. This becomes a -3, this becomes 6, and this is 0. Okay, 2 cancel, this becomes 3. 2 2s are 4, 3 2s are 6. This we will get 0, and that is 2 we have. Hello everyone. Now let's name each and every by finding the width of this function. What is the central width of this function? Let us remove all the thing. See, this is the x of t. So this means that this is having a width of, how much? Width is 4. Width is 4. But what is the width of this function? Come on. The width of this function is upper bound minus lower bound 2. What is the width of this function? What is the width of this function? This is width is 12. What is the width of this function? Come on. How will you find out the width of this function? Come on. Width, how will you find? Upper bound is 0. This is the width, no? This is the width, sorry. This is the width. So, how will you find? This is the upper bound, 0 minus lower bound, minus 4. 0 minus of minus 4. Still it is 4. Okay? And how will you find the width of this function? How will you find out the width? This is the width of this function. Okay, this is this. So how will you find out the width of this function? 0 minus of minus 6. It is 6. This is the width. Width is. Now my point is that, see here, look at the signal. This is having a width of 4. This is having a width of 4. But when you take x of 2, this means that here, what is the value of alpha? Alpha is greater than 1. Listen, if the format is yt, which is equal to x alpha t, here I have taken alpha to be greater than 1, and we will get the width lesser than that. This means that, let us call this operation time compression. Where alpha is less than 1. This is what a time compression is. Next, see, look at the original width. Please don't forget the original width. Original width is 4. So what's this width? Width is 12. Width is 12. This means that this is time expansion. This I am calling it to be a time expansion. Yes, alpha is greater than 1. Sorry, I have written somewhere. Yes, alpha is greater than 1. Here, this is alpha is greater than 0 but less than 1. Time expansion. Time expansion, alpha greater than 0, less than 1. That's what the time expansion means. What is time reversal? Alpha equal to minus 1. Alpha equal to minus 1. So if alpha is equal to minus 1, this is what? This is what? Nothing but a time expansion. Time reversal. And what about the last one? Last one, see, this is reversal. Reversal plus either expansion or compression. Mind it. How will you decide that it is the expansion or compression? Just take x alpha t. And alpha is less than 0. Alpha is less than 0. If mod alpha is greater than 1, it is compression. If mod alpha is greater than 0, less than 1, it is alpha is less than 0. Let me write here, alpha is less than 0. If it is expansion. Expansion. What I want to say is that, see here, what I want to say that here minus 2 by 3 is, it is reversal, that is for sure. But look at the 2 by 3. 2 by 3 is less than 1, means greater than 0, less than 1. So here what is mod alpha? Mod alpha, if you take this mod minus 2 by 3, it is greater than 0, less than 1. This means that this will be 100% expansion. Means it is reversal plus expansion. Surely, 101%. Just check at the value, just check at the coefficient t. What is the coefficient t? Coefficient t is minus 2 by 3. Minus means reversal. And take the mod. Mod is greater than 0, less than 1. Definitely you will get expanded. And how will you check? Yes, sir, original width is 4, but my width that I am getting here is 6. Look at that. This means that it is an expanded version of a function. Is this point is clear to you guys? So this is how I expand it. So let me summarize everything. So I have a time scaling. So time scaling, I have the format is yt is x of alpha t. This is what my yt is. Yt is x of alpha t. So if alpha is greater than 1, it is compression. If alpha is greater than 1, greater than 0, but less than 1, it is expansion. If alpha is equal to minus 1, it is reversal. If alpha is, here two cases we have, here two case. Alpha is greater than 0, less than 1, mod alpha is, it is reversal plus expansion. When alpha is less than 0, and if mod alpha is greater than 1, it is reversal plus compression. Hope this complete chart will help you in your gate exam, because many times guys, number of times you will get a problems from this one. Number of times you will get problem from this one, guys. That's one of the most important point that I have to take care of. This is a complete nothing but my time scale. So I do not have to cover time reversal, guys. Okay, I do not have to cover time reversal. See, I already covered time reversal. What is time reversal? Time reversal is a special case of time scaling where alpha is equal to minus 1. Time reversal is a special case of time scaling where alpha is equal to minus 1. That's a very important point. Okay, so that's what the whole thing is. Now my question to you is very simple, that okay sir, individually I understand time shifting, time scaling, time reversal. What if I have a combined operation of x of alpha t plus beta? This means that I may have time scaling, I may have time reversal, I may have everything. How will you combine all this? And what is the format? What is the way to handle these kind of questions? This means that what I want to say is that I want a combined operation. Combined operation. Listen carefully now. Combined operation. What do you mean by combined operation? See here. Suppose I have x of t is defined. Let's take x of t form also. Suppose I have x of t. This is x of t is defined. This point is minus a, this is b, this is c. Everything is defined. Suppose I want, this is x of t. I call it to be x of t. Suppose I want yt to be equal to x of alpha t plus beta, where alpha comma beta belongs to real number. ये बहुत important बात है. This is a very important point. You should remember, everything inside the bracket must be a real number, okay? Otherwise the operation is not defined, because the x-axis itself is a real number. Now my point is that how will you perform this one? For example, suppose I want x to be, xt is defined, I want yt to be x of minus 3t plus 12. How will you perform this? Question is this one. Yt is defined, so how will you perform x of minus 3t plus 12? That's a very important point that you have to take care of. Okay, let's do it. See here, first of all, now in this topic I will give you the proof, every proof that I have made so far, that for shifting you have to either add or either subtract, and for, let's say, for scaling you have to divide by alpha. The proof comes here. How will you perform x of alpha t? Now listen carefully. See here. If you have x of alpha t plus beta, what is the way? Sir, first I will do shifting and then scaling and then reversal, or first I will scale or scale and then I will shift and then I will do reversal. What should be the way to perform this operation? I will give you by the proof. Any way you may opt, no matter whatever the way you are opting, your answer must be remain same. See, what I want to say is that x of alpha t plus beta, see, how will you perform this? See, any way you may perform, it doesn't matter. See here, this is x of alpha t plus beta. This is x of alpha t plus beta. What I am doing is that I will go in this way. I will go in this way. This means that, see here, I will take alpha to be common and this is t plus beta by alpha. T to be beta by alpha. So what I am doing is that if I go in this way, then I will scale by alpha and shift by beta by alpha. This is the one way. If you go in this way, x of alpha t plus beta, in this way, from left to right, then shift by beta, and scale by alpha. So any way you will opt, the answer will remain same. What is the mathematical base? Let's give you the mathematical proof. Mathematical base. See here. Suppose what I am doing is that I am defining the function in between minus a comma b for t. For t. This means that here t is defined for minus a comma b. Listen carefully now. And suppose this, replace this t by alpha t plus beta for the same limit. Okay, replace this t by alpha t plus beta for the same limit, and if you solve for t, there are two ways to solve for this inequality for t. First way, let me solve in this way and let me solve here. See here, what is the first way? It is minus a comma alpha t plus beta and less than b. What I am doing is that, see, let's take alpha to be common here. Let's take alpha. So it is a minus a comma alpha and here t plus beta by alpha to be less than b. I want to solve for t, mind it. I want to solve for t. So how will you solve for t? Simply divide it by alpha both the side. This means that it becomes a minus a by alpha less than equal to t plus beta by alpha less than equal to b by alpha. And when you solve for t, what do you get? You will get minus a minus beta by alpha less than equal to t less than equal to b minus beta by alpha. See here? Simply take alpha to be common, divide both the side by alpha and simply shift by beta by alpha. Here, instead of doing this, what I will solve, I want to solve for minus a comma alpha t plus beta and less than b. What I am doing is that instead of taking alpha to be common, shifting beta both the side. This means that subtracting beta both the side, minus a minus beta less than alpha t less than b minus beta, and then dividing by alpha, it will gives you minus a minus beta by alpha less than t less than b minus beta by alpha. So if you solve for t, don't you think that both the limits are same? See, look at the limits. These are the limits, huh? These are the limits. These are the limits. See, these are the limits, and here this is the limit. Sorry, this is the limit. What my point is that all the limits are same. So it doesn't matter that whether you shift first and then scale, or whether you scale first then shift. It doesn't matter at all. Answer must remain the same. The only thing you have to take care is that whenever you scale, you have to take whole coefficient factor to be common. Once you take the whole coefficient factor to be common, then the shift factor will be minus beta by alpha. So here shifting factor is beta by alpha, not beta. That's the important thing you have to take care of. We say that this is the RHS way, right hand side way, means I will go in this way, see, and this I am calling it with the left hand side way. I will go in this way, I will go in this way, then whatever operation says, simply perform the operation. Whatever the operation says, simply perform the operation. Okay, this means that, see here, and now you get the answer why. For shifting, see here, plus beta denotes shifting, and for shifting what I did either subtract or add depending on the values of alpha, depending on the values of that shifting factor. Here shifting factor is beta, that's why I subtracted both the side. Now for scaling, the coefficient of alpha can only be handled when you divide it. That's why I said that in the scaling, simply divided by alpha. Here also, see, look at that. For shifting, what you do? Simply subtract beta both the side. Depending on the sign of beta, it will either be plus or minus, whatever. And for operating on alpha, that is a scaling, simply you have to divide it both the sides. See, that's why when I say the time scaling operation, simply divided by alpha, whatever it is, simply divided by alpha. You understand my point or not? My point is very simple, that whenever you have a scaling, reversal and shifting, then the order doesn't mean just you have to simply do it. Either you will perform in this way, either you will perform in this way. Your answer will remain the same. And let me check you in the one of the very interesting problem. Let me check you in very interesting problem. Let's do it. Suppose I have a function, again x of t I am taking, example x of t I am taking. Suppose I have x of t to be, okay, this one. This is 0, this is 2, this is 4, that is 6, this is 2, that is 4. Okay, this is the signal, and this is x of t. This is example, this is x of t. Suppose I want to plot yt, which is x of 2t plus 6. Let's take some different, minus 2t minus 6. Now I will perform both the sides. I will perform from both the sides. Minus 2t minus 6, I will perform either from right hand side or left hand side. How many ways are there? 2 ways are there. 2 ways are there. How? Sir, I will take x of minus 2t minus 6. So I will take x minus 2 to be common and then replace by t plus of 3. So what I will do? I will reverse, then scale by 2, and then left shift by 3. Left shift by 3. This is the one way. There is another way also. Another way is that I want to perform x of minus 2t minus 6. So I have to first left shift by, sorry, not left shift, right shift by 6 because of this minus sign, then scale by 2, and then shift by, reverse. So in this operation, I will go from here. In this operation, I will go from here. And what I am claiming that both the way will give you a same answer. So let us call this to be the RHS approach, and let us call it to be the LHS approach, whatever. Right side approach, not RHS. Okay, it is RS approach. Right side approach, it is left side approach. And my claim is very simple, that I will get a same signals. Okay, do it. Let's perform by RS approach first. RS approach by RS. What it says, first reverse it. First reverse it. When you reverse it, I will get this one. This one, this is the reversal. This becomes a 0, this becomes a minus 2, this becomes a minus 4, this becomes a minus 6. You do not have to worry about y-axis value, they will never change. Reverse, then scale by 2. Simply scale by 2. How you will scale by 2? I just told you that what is the scaling? Scaling is simply divided by 2. This means that simply divided by 2. So this should be 0, this is minus 1, this is minus 2, this is minus 3, and that is 2, this is 4. Now what you have to do? So you have to left shift by 3. Mind it, left shift by 3, not the right shift, left shift by 3. This means that whatever you have at 0, it becomes a minus 3. Whatever you have minus 1, it becomes a minus 4. It is minus 5 and it is minus 6. This means that I will get, okay, let's take in a fresh page, I will get here. Here. And what is the values? The values are, this becomes a 0, this becomes a 0, becomes a minus 3, minus 4, minus 5, minus 6. Minus 3, minus 4, minus 5, minus 6, it is 2, it is 4. That's what the RS approach is. Let's talk about the LS approach. LS approach. Okay. Left side approach. What is the left side approach? First you have to shift the signal by 6, right side. Just shift the signal by 6. So do it. What you will get? I will get this. And what are the points? Becomes minus 6, minus 8, minus 10 and minus 12. So it is a minus 6, minus 8, plus 6, plus 8, plus 10 and plus 12. This is 2, this is 4. So 0 becomes a 6. That's what the meaning of RS by 6. Then scale by 2. So just scale it by 2. Scale by 2. Same thing. So this is 3. This becomes 4. This becomes 5. And this becomes 6. This is 2. That is 4. And now what do you have to do? You have performed this, you have performed this. Now you have to just simply reverse. So simply reverse it. When you reverse it, don't you think that I will get this signal? See? What are the points? The points are simply minus 3, minus 4, minus 5, minus 6, which is same. Look, which is same 2, 4. See, here also the width is, what is the width? Width is -3 minus of -6, which is 3. Here also the width is same. Width is 3. And width will remain the same. So this is, we call it to be a combined operation on x-axis. This is what we call it to be a combined operation on x-axis. Mind it. One of the most important topic that we have covered today in today's class. Okay, same thing we will perform in the details also in the next class. But x-axis operation is very important. X-axis operation is one of the most important operation we have. Now one thing is that, see here, if suppose someone asks you that without plotting find out the width of this signal, find the width of, let's say, let me ask this signal above, in above question, without plotting, plot, comment on width of yt. See, look at the x of t. What is the x of t width? X of t width is very simple, 6. Xt width is 6. So what I am saying is that xt, change the color, xt width is 6, and I want to know if yt is x of what? Minus 2t minus 6, x of minus 2t minus 6. I want a width to be in general without plot. See here, in general I am saying that suppose I have x of t having a width of w, and if I want to perform yt to be equal to x of alpha t plus beta, then we can comment on width, guys. Who will decide the width? Alpha. Who will decide the width? Alpha will decide the width. This means that no matter whether you go by right side or left side, it doesn't matter at all. Shifting will not change the width. Shifting, I told you in the this class itself that shifting will not change the width. Who will change the width? Alpha. But the point here is that alpha may be positive, alpha may be negative. Okay? Here alpha may be positive or negative also. But width is a scalar quantity, not a vector quantity. You never say that my width is -3. Okay? This means that if alpha is positive, then alpha has to be positive, then yt must have a width to be equal to w by mod alpha. Yt width is, this is width of yt. Hello? W by mod alpha. Why mod? Because alpha may be negative and it does not create an impact on the, as far as your width is concerned. So this means that as long as your signal is defined and its width is defined, then we can find out the width directly by taking the coefficient factor. So if coefficient factor is 1, then width will not change. If coefficient factor is there, then width will change. For example, in this signal, width is 6. What is the new width? 6 divided by, what is the alpha here? -2. So it is a mod of -2, and this should be equal to 3. And check it, that width is 3. Okay? So width will only depends on nothing but my alpha. And there's a question, guys, because width will decide the energy of a signal that we are going to cover in the upcoming classes. So width will decides energy, width will decides many things. Okay? And hence the point is that you do not have to plot everything every time to comment on the width on the signal. Width you can find out directly also. Is this point is clear to you? Hello everyone, is this point is clear? Is this point is clear to you everyone? Hello. So width, I think you can find out directly by changing the values of nothing but my alpha. Okay, by finding the values of alpha. Now I am giving you the homework. Let us take one homework before we conclude the class. Homework. I have this kind of signals. This is the signal. 0, 2, 4, 6, 8 and 10. This value is 4. This value is 8. This value is 12. This is the slope we have, okay, in between. This is x of t. Plot yt equal to a x minus 60 plus 4, b yt equal to x minus 2t plus 12. Okay, minus 2t plus 12, let's call it, let's take some coefficient also. This is 4 and that is 3. This is the homework for you. I have multiplied some coefficient also. So this means that this time the y-axis value will also change. So 3x minus 2t plus 12 I want, and I want a plot, and without commenting, without plotting, also comment on width on each operation. ओके हो जाएगा? कम ऑन, क्या ये हो जाएगा? हेलो एवरीवन, बन जाएगा ये? यू कैन कवर दिस, ऐसा नो? Just go through the whole classes and you will surely able to perform this one. Okay, so what we have covered till now, we have covered x-axis operation, x-axis operation on CDS, in which we have covered time shifting, time scaling, and we have covered time reversal also. We have covered time reversal also. Okay, so these are the points that we have covered. In the next class we are going to cover the same thing in DTS, and we will conclude the whole operations. Y-axis operations we will also perform in the next class. Okay, and this is the point that we are going to cover in the future classes. So next class itself is very important. Then we will talk about the elementary signals and all in the forthcoming lecture. Mind it that the lecture is exactly same as your paid batch. So do respect it and please attend in a rigorous manner, daily at least, without fail. So with this, if you have doubt, then you may ask the doubt. With this, thank you very much. Thank you guys. If you have doubt, I am standing here for 1 or 2 minutes and then we will conclude it. Okay. I don't think there is a doubt. Thank you very much.